Brent oil and gas field has provided energy for the UK for 40 years. A joint venture between Shell and ExxonMobil, it's created and sustained tens of thousands of jobs and delivered a number of technology firsts. At its peak, it produced enough energy to power half the UK's homes. But with reserves now depleted, Brent will follow in the footsteps of dozens of other North Sea platforms and be decommissioned. As the operator, Shell has to recommend the best methods of doing that. The Brent field is made up of 4 platforms, 154 wells, and 103 kilometres of pipeline.
It's an enormous task. The platforms are interconnected and interdependent, so that adds to the complexity.
These mega structures were built to withstand 200-mile-per-hour winds and waves 25 metres high. Their robust design raises challenges for today's engineers. This will be Shell's biggest decommissioning project and one of the largest undertaken in the North Sea.
What often surprises people is that these platforms weren't designed with decommissioning in mind. They were designed at the height of an energy crisis to extract the oil and gas from the reservoir.
Shell's collaborated in the development of a bespoke solution to remove oil trapped in subsea storage cells. It's also collecting debris that's been washed off the platforms during storms.
We have 154 wells, and that's actually where a lot of the effort in decommissioning goes into plugging and making safe those wells so the reservoir doesn't leak in the future.
Over 1.7 million litres of concrete has been used so far to permanently seal wells. Plans are also in place to remove the 4 topsides. Together, the topsides weigh a colossal 93,000 tonnes. They'll be cut from their legs, and in the world's largest ever offshore lift, they'll be transferred onto a barge and sailed to shore. 97% of the structures will be recycled. For the other parts of the field, Shell has completed a comparative assessment. This weighs up the pros and cons of each decommissioning option under 5 main criteria: safety, environmental, societal, economic, and technical. Hundreds of expert studies have been commissioned and the results analysed and verified by a group of independent scientists.
I really feel very strongly indeed that having truly independent review is a vital part of this process.
Shell has shared its findings widely with interested parties. Their feedback, the results of the comparative assessment, and the independently verified research has informed Shell's recommendations for decommissioning the Brent field.
Gravity-based structure, or GBS as we call it, is made up of a steel skirt which anchors the structure to the bottom of the seabed. It's made up of some cells for storage and legs.
These gravity-based structures are made of heavily reinforced concrete. Each GBS weighs around 300,000 tonnes.
Shell has investigated completely removing the structures from the sea.
When these GBSs were positioned out offshore in the 1970s, they would have been towed out, filled with ballast to ensure that they were grounded on the seabed.
To refloat the gravity-based structures, this installation would need to be reversed. Cells would need to be emptied, sealed, and filled with air to induce buoyancy. The base would need to be excavated and hydraulics used to prise it from the sea floor. And a method of altering the buoyancy would need to be found for its journey to the surface. Independent studies suggest that successfully refloating the GBS would prove extremely difficult.
Nobody's ever done this before. You can have a scenario pop up where you would lose control of the GBS structure.
Attempting to lift the structures from the seabed could also collapse them.
It is technically extremely high risk of failure and also a very high safety risk far higher than we would accept in any other part of our operations.
Based on 30 years of data gathered on North Sea operations, that would indicate that we'd have at least one fatality per gravity-based structure being refloated. And that is a risk which I am not prepared to entertain.
So having done some deep technical studies and also dialogue with our independent review group, we've come to the conclusion that we won't carry that option forward.
Shell has also considered leaving the GBS in place and adding navigation aids, or cutting the legs 55 metres below sea level in line with International Maritime Organisation guidelines.
To better understand the complexity around cutting concrete is we have actually done some trials onshore where we've formed reinforced concrete. And we've also compressed it to try and replicate the conditions that are out there actually on the GBSs.
While they've achieved the cut in a test on land, there's concern it may not work in practice.
As you may appreciate, making a cut without trapping that wire with 6,000 tonnes of dead weight bearing down on that cut surface in a marine environment where you're dealing with the effects of waves, wind, a dynamic situation is certainly extremely challenging.
The cost of this partial removal would be very high, which is something Shell is required to consider.
The UK taxpayer will be funding part of the cost of decommissioning, so it's really important that the operators are looking to carry out the work in the most cost-effective manner.
Brent's profits were taxed in excess of 70%. It paid £20 billion in today's money in taxes. Shell can now claim a 70% reimbursement on the cost of decommissioning from the taxes it previously paid. And while the final costs of decommissioning are not yet known, Brent will remain an overwhelmingly positive contributor to the UK Treasury. Having weighed up all the options, Shell is not recommending the partial removal of the legs.
Our recommendation, based on 10 years of study and independent review and analysis by our independent review group, is to leave the concrete gravity-based structures with the legs up in place.
This would involve capping the legs with concrete and installing navigation aids. The structures would be marked on maritime charts and in FishSafe, the fisherman's GPS warning system.
One of our key contractors came to the conclusion that actually the collision hazard was about 1 in every 10,000 years, so well under any accepted standard.
Experts estimate that the GBS legs will degrade to below sea level in around 250 years. Then their position would be marked with buoys.
The option to leave the gravity-based structure in place really mirrors what's already happened in the Norwegian sector, where the structures have been left in place with navigation aids on there to aid shipping and fishing.
As a general principle, the fishing view is if it's going to be there and going to cause an obstruction, then let's be able to see it. Legs up is the choice of the fisherman.
Inside the gravity-based structure, there are storage cells which have been used to collect oil in and stored there until it could be pumped away to a tanker or via pipeline.
So this is a model of the Brent Delta gravity-based structure. You can see at the bottom there are 16 storage cells, and this is a cross-section through one of these 16 cells. It's a reinforced concrete structure. The concrete is around 1 metre thick.
There are 64 cells across the whole field. Each is 60 metres high and 20 metres in diameter. Before Shell could recommend a method of decommissioning, the team needed to investigate their contents.
We drilled through the concrete at the top of 3 of the cells and lowered a series of liquid sampling and sediment sampling tools all the way down so that we could capture physical samples.
An unlikely partnership also helped the team better understand what it was dealing with.
This is a sonar sphere, which we developed in conjunction with NASA. And what we were able to do with this is to put it down through self-fill lines and into the storage cells. And on the front, we have a small sonar, which is what we used to characterize the volume of sediment that was in the base of one of the cells.
The sampling and sonar revealed an average of 4 metres of sediment in 42 of the cells. This material was independently analysed.
The samples for the sediment certainly showed that the material was more benign than we thought.
The cell's contents were revealed to be 25% oil, 25% sand, and 50% water. Shell understood people's interest in the cell contents, so it set up a task group of interested parties, including academics, scientists, and environmental organisations. Shell then assessed various options, some for leaving the sediment in place, and others for removing it.
Removing the contents of the cells is a very demanding operation. It would require cutting a hole into the cell itself, so kind of penetrating that nearly metre-thick reinforced concrete. Probably need to be quite a large, sizable hole to put dredging equipment into the cells.
If this could be achieved, the sediment could either be shipped to shore by a fleet of tankers or re-injected into the reservoir via a series of new wells.
It's an enormous operation. It's a multi-season campaign. We think this isn't the right option.
The team also considered options for leaving the sediment in place. They worked with specialists at DNVGL to identify and assess any risks and predict potential environmental impact.
We've had marine toxicologists, marine ecotoxicology, underwater noise specialists.
They considered injecting additives into the cells to attempt to reduce the amount of contaminant.
While this had benefit, it was limited in its benefit because the cell sediment could be 4 metres thick, but the nutrients will only really affect the top layer of that, maybe 10, 20 centimetres.
They also looked at capping the sediment with a protective layer of bentonite and sand.
The additional complexity associated with the capping option was that the sediment itself had a very low bearing capacity, and therefore any capping layer you put on top would likely fall into the sediment.
Specialists predict that when the cells degrade and the sediment is eventually released, any impact on the environment is likely to be restricted to a small area very close to the structures.
It sounds slightly counterintuitive, but on balance, it makes more sense to leave the sediment to degrade naturally as it is entombed within the cells.
When Brent's wells were drilled, shards of rock were discharged into the sea around all 4 platforms. These drill cuttings remain on the seafloor and cell tops. They've been independently assessed to see if they fall within acceptable limits set by the UK regulator and OSPAR.
There's quite a large volume of drill cuttings there. Our specialists looked at them, they've considered the environmental impacts, and what was found was that at Brent Alpha and Brent Delta, that they were within OSPAR limits. Brent Charlie, they were fine at the seabed, but the cell top exceeded one of the OSPAR criteria in terms of the oil load released.
Though some exceed acceptable limits, removing them could worsen their environmental impact.
Mobilising the drill cuttings is like stirring up a muddy puddle. If you just leave the puddle as it is, it's got clear water. As soon as you start to mobilise it, you've then got a more complex problem.
If you disturb them, the disturbance itself will create pollution and release the oil.
Shell recommends leaving all the drill cuttings undisturbed, an option the regulator has approved before. Brent Alpha's legs, or jacket, will be removed and sailed to shore, allowing 10,000 tonnes of steel to be recycled. But below the legs are footings, giant steel piles filled with cement pinning the structure to the seabed. Shell has studied various methods of decommissioning them.
The footings would require excavation into the seabed to conduct an external cut of those footings.
We would then have to do the actual cuts using some sort of technique like diamond wire cutting or high-pressure water abrasive cutting.
And then you've got the safety risk of those conducting the operation, either through remotely operated vehicles or through divers to actually allow that cut to take place.
As part of their comparative assessment, Shell commissioned independent studies to assess the consequences of leaving the footings in place.
The outcome of that CA for the jacket from environmental aspects is very low impact if we leave those footings in place.
Shell's recommended option for the alpha footings is to enter them into the fish-safe system and leave them.
We're prepared to live with that, provided the footings are well and truly established in fish-safe, so that it is entirely possible to know exactly what is there and exactly where it is.
So there's 28 different pipelines in the Brent field that we are looking at for decommissioning. These vary in size from kind of 3 inches up to over 30 inches in diameter.
Some of them are more like flexible hoses, in fact, and some of them are buried, some of them are laid on the seabed.
Shell is recommending a range of options for dealing with the 103 kilometres of pipeline. Flushing and leaving them, covering them with rock to bury them, digging them into trenches, or removing them.
Smaller lines are relatively easy to reverse reel, so we would remove them. For the very big lines, often they're concrete coated to keep them on the seabed, they're buried.
North Sea fishermen trawl over existing pipelines, which are all marked on the fish-safe system.
Living with pipelines has been a feature of our life for the last 50 years. If a pipeline is trenched and buried and has been for its life, then often the removal of it causes more problems than leaving it there.
After 10 years of research, Shell will be submitting their decommissioning recommendations to the Department for Business, Energy and Industrial Strategy. A 60-day public consultation will take place, with the full decommissioning report available on Shell's website.
We are, of course, always open to new views. If there is anything that we've not thought of, then, of course, we are more than willing to listen and learn.
The UK regulator will decide whether or not to accept Shell's recommendations. If they allow the items to be left in place, there will be ongoing work for Shell to do.
If we leave the structures in place, of course, it doesn't stop there. We have liability on the structures forever. We will also be monitoring the structures and the environment around them.
We clearly want to do the right thing and have spent many years studying the issue to understand what that right thing is. What we've come to is a very robust and really in-depth decommissioning proposal.
After a 40-year lifespan and a decade of research, the final decisions for decommissioning the Brent field will soon be known.